So it's about 22 hours or so until the FSE exam. And when I used to take exams, I really used to hate this time because I used to think, I haven't got enough time to do as much revision as I'd wanted to. This exam's at the end and I wasn't really thinking about it. And I just used to find having a whole bunch of exams together really difficult. So I used to be the queen of last minute revision. My memory's really good and that really helped with this. But that was only on the basis of the fact that I'd actually been to stuff and I could actually remember what it was that people had said. And I'd also written stuff down and left post-its lying around for myself to help myself with my revision. But some of you might not have done that. And I still would like you to pass my exam. So I thought I'd record a last-minute cramming session podcast for you guys to watch. So the aim of me doing this is to enable you to cram as much as possible into the next 22 hours in order to be able to pass my exam. What I'm not going to do is record every single lecture that I've been through and be able to recount everything that was said in every lecture. What I'm aiming to do is to provide a really quick overview of the major concepts that we went through in software engineering and refresh your memory and explain some of the words. So if you are having trouble with your revision, then you can make a little bit better progress and hopefully explain yourselves a bit better tomorrow. Again, what I'm not going to do is I'm not going to tell you exactly what's on the exam because it's an exam, despite having lots of questions about this. Pretty much all of the content I'm going to say on this podcast is contained within the lecture slides. I'm going to be reading some of the lecture slides while I'm telling you this to remind me what it is I want to say. So yes, you can switch off at this point and just read the lecture slides. It's entirely up to you. I really don't mind. But the idea is to get your brain focused onto the task of actually understanding the various concepts and how you can use them. And that's what you're going to be examined on tomorrow. So without further ado, we move to part one. Part one is the software engineering process. So start with some basic definitions. What is software engineering? We went through this very early on in the term while most of you are still coming to the 9 o'clock lectures. So it's a bit difficult to define. It's a bit of a young field. It's not really been around for very long. But the standard definition of the software engineering process is that, I quote, "It's the application of a systematic, disciplined, quantifiable approach to the development, operation and maintenance of software and the study of these approaches." What this means is that we don't just develop software in a bit of an ad hoc or random way or however we feel like doing it. Because software engineering often happens in teams, we need to work together. First and foremost, we need to work together. And to facilitate people working together, you generally need an agreed structure or an agreed framework in which this can happen. Software engineering methodologies are the framework which you use to develop software as a collective or as a group of people. It's systematic because there are certain stages which you have to complete before other stages, and we'll go on to talk about what these stages are. It's disciplined, which means that each of the different stages has a prescribed set of goals and objectives which generally are adhered to. It's a quantifiable approach. This means that you can assess when certain objectives have been met. And the goal of this is to produce software which is of a professional standard, which is understandable, which has got very low amounts of bugs and errors in it, and also to produce software which satisfies the requirements of the consumer, the customer, or the stakeholder. So, why do we bother with software engineering? Well, there's a whole number of reasons. It's all right, really, to develop software without too much of a process if you're just developing one object class and you've only got 200 lines of code to solve one particular problem. This is the typical scenario that you get in coursework that we give you in your first year, right? The majority of software engineering projects are not like this. The majority are actually very big, got lots of people working on them. You've got lots of bits of software that have been developed independently that you have to bring together to build a massive system. I mean, if you think about an operating system, you think about how many lines of code something like Windows 7 has, or even something simpler like the Android operating system running on mobile phones. It's still a lot of code to work together. There are lots of modules. There's a lot of potential for things to go a lot wrong. Unfortunately, in the past, where good methodologies haven't been used, there have been some quite tragic consequences to this, both in loss of time, productivity, and human life. The most famous example of a badly managed software engineering escapade was the Ariane 5 rocket, which went bang because parts of the software weren't correctly tested. If a better methodology had been followed, this tragedy could have been averted. The NHS infrastructure, we still can't turn up at an A&E in somewhere like York and get instant access to our medical records residing in our GP. There are too many security challenges. There are too many issues with data confidentiality. And again, this project has not been approached as a software development project, where small systems are rolled out, pilot systems are rolled out in certain NHS primary trusts. But no, what's happened is they tried to build a unified system to encompass the whole country. And because it was top-down approach planned, rather like the construction of a motorway, it hasn't happened and it hasn't worked. And it's cost some millions, if not billions of pounds of development. And also the guys in Leicester who sent the Beagle Mars rover to the moon, they had a landing system bug and it never made it. Okay, so that's just a few trivial, not trivial, but commonplace examples of what happens if you don't engineer your software correctly. So hopefully after sitting through hours and hours and hours in these lectures, you will understand exactly why software engineering is important. If not, there are 3 examples. So why exactly do we teach it? Well, the majority of you, according to our alumni figures, are going to end up being developers of some sort, whether it's on the testing side of things, whether you're going to be web developers, whether you're going to work with embedded systems or for GCHQ. Most of you will become developers at some point in your career. In industry, you're going to be working as a team. You're not going to be able to sit and develop software by yourself. You'll be working to somebody else's deadlines. You don't have the flexibility to pick them yourself. And also sometimes things such as deadline extensions don't exist. And if you need to extend a deadline, you might be costing your company millions of pounds, which you don't really want to do. And also when you get to interviews for these jobs, it's expected that you're going to understand this jargon. It's not just jargon, it's a common language which software engineers use to communicate between each other, to say precisely how a piece of software needs to be developed. If you don't understand the standards for this development, you're not going to be a very good software engineer, and you're not going to progress through the ranks as perhaps quickly as you could do in comparison with your talent as a developer. There are loads of different types of methods that people use to develop software, and what I'm going to do later on in this podcast is go through a couple of these methods. So not only does software engineering have a jargon or a little language of its own, but also different companies adopt methods and adapt methods to suit their own requirements for software development. So it's important that you understand what the basics are before you get chucked in at the deep end with something like this. And these methodologies and these techniques, we are going to reinforce these over the years as part of your degree course. And we will expect you to use this jargon in reports in the future, just as a lot of you did very well in your coursework. Also, source code is often edited by multiple people across lengthy time periods and involves customers as well. This makes it quite a messy process. If you don't have something to unify that process, it makes it very difficult to produce anything of any sort of substantial quality. So that's the point of software engineering.